Okay, so we'll be able to look at the sequencing rules.
Recording in progress.
Okay. So now here, sequencing rules, there are, of course, there are these ones. There are 4 of them. First come, first serve. Okay, like I've mentioned, for first come, first serve, we have the shortest processing time, the critical ratio, and the earliest due date. Okay. Now, to evaluate each sequencing rule, to evaluate each sequencing rule, we use the following. Number 1, we use average flow time. So average flow time. This is the completion time for the job. Completion time, okay, for the job. Then you have average job lateness. And average number of jobs in the system. Average number of jobs in the system. So these are the criteria that we use to evaluate each sequencing rule. Okay. So the smaller of each of them, the smaller flow time. So smaller flow time, smaller job lateness, and the few smaller jobs in the system is better. Okay, smaller jobs in the system is better. All right, so if you're able to complete jobs very fast, then they'll measure your efficiency. Okay, the efficiency is measured by that. And of course, we have the smaller lateness, the better. You can measure it, you can evaluate someone if there's a smaller, if the lateness is very minimal, it's good for evaluation. Okay, the smaller the flow time, the smaller jobs in the system is better. Okay, so now in an exam, they'll give you the first, they only give you the first come first serve, and other sequencing rules come from the first come first serve. So what are we given here? You can read for me the question. It says what? What is the question?
The workshop manager at Toyota Zambia Service Center must decide the sequence in which the 4 vehicles in the workshop must be serviced. He has developed these estimates based on the first come serve sequencing rule. That is the table there. Then rank the first come first service. Then this one shortest processing time and critical ratio sequencing rule on 3 evaluation criteria: average flow time, average number of jobs in the system, and average job lateness.
Okay, so what is going to happen is, so this is how the vehicle arrived at Zambia Toyota. The first one that arrived area was 226, 229 came second, 224 came third, 225 came fourth, right?
Yes.
Okay, so that's the first come first serve. So you rank the first come first serve total processing time and critical ratio on the three evaluating criteria: average flow time, average number of jobs in the system, and average job lateness. So what you do, you don't have to waste time. The solution here, you is going to be this way. So this is how the jobs came. So here we have what we call first come, first served table. Okay, so first come, first served table. So we have the vehicle ID. So estimated maintenance time is the same as the processing time. Then this other one, you say due date, which is the time to promise delivery. Then you go for flow time. Then you go for job lateness. So regardless of the sequence, you should have these 5 columns. Are we together? I'm sure you're with me. Okay. So
Yes, I'm following you.
okay, so now here it was 226, 229, 224, 225. Processing time was 27, 33, 41, 29. Due date was 39, 30, 60, and 75. Then let's fill in up the flow time. Flow time is the cumulative frequency of processing time. So flow time is the cumulative frequency. Okay, so it's made of frequency of what? Of processing time. Okay, so frequency of processing time. So what will be our flow time? Here it will be 27. 27 plus 33 is 60, 101, and 130. Cumulative frequency of processing time. Then our job lateness will be what? If you pass the due date, you are late. So job lateness means, okay, flow time greater than due date. Flow time greater than due date. That is on job lateness. So here, the due date is 39. We have finished working in 27, so we are not late for the first one. Okay? 27 and 39, we make a comparison between these two to determine the job lateness. So here we are not late. Here we are late by 30 days. The difference between these two.
I think I'm a bit behind. Yeah.
Yes. So when you pass the due date, you are late. So compare the flow time and the due date. The due
I
date.
just want you to go back to the question. You see the table, the given table there.
Is here.
Okay.
So this guy is called processing time. So this one was first come, first served table. So don't tamper with it. So it's the
Okay,
first.
so it is.
Yeah, just take it the way it is. First come, first served.
Then that one.
This is the due date.
Time to promise delivery. Oh, that's it. That's another terminology. Okay. So also it remains the way it is.
Yes, this one also remains the way it is for the first come, first served basis.
Okay. Then just add the flow time.
And the job lateness.
So you just add the criteria, the averages. That is the flow time job lateness.
No. When you have this table here in an exam, regardless, so this is vehicle ID, this is how the vehicles arrive. So processing time, the due date, you've seen the due date, right?
Yeah.
Is that okay?
Yes.
Vehicle ID, processing time, the due date. Then I've incorporated the other things, which are those? The flow time and the job lateness. You've seen.
So we get away with the first come table, first come, first service.
What are you saying?
Score. That one is to maintain. The next one also you maintain. The third one. Then you just remove the first come, first service table. Instead, we put the flow time and job lateness.
What we do what?
Going by the initial table.
This
in the question.
This is the same table which is here. I just book lifted these values here. This column do the same, this one the same, this one the same.
Then you remove the first come, first service, right?
Which one?
That one. You get away with it.
This was just a order, yes. This was just a order how this vehicles arrived. It's not necessary.
Okay.
So the first vehicle that came in was one for service. The second one was 229. The other one was 224. The other one was 225. Is that okay?
Yeah, I've seen. And then on the criteria, they're asking about, I mean, us to do three things, but we've only, the other things are there. Processing time is there.
Yeah, so I will show you. The flow time is, but they asked about what? Three things, not so. What are those? They asked us to do what?
Average number of jobs in the system, the same as processing time, right?
Average job rate, average number of jobs in the system, and average flow time, not so. Is that okay? Is that okay with you?
Yes, madam.
Hello?
$75. 55. 55?
You left by how much?
55.
130 minus what? 75 by 55.
55.
So now, calculate for me from here, calculate for me. So if we evaluate this table, let's evaluate first come, first served table. So find the average flow time. I'm using the short. So if I find the total, what's the total here for the flow time? What are the totals? For the processing time, the total is 130 here. Okay. So the total is 130 here. The total for this one, let's add 27 plus 60 plus 101 plus 130. The total is what? 318. What's the total for the lateness? 30 plus 41 plus 55 is 126. Altogether. So what is the average flow time? Average flow time is 318 divided by 4. Okay, so 318 divided by 4. There are 4 jobs, not so. Our average job lateness, you can write in full. Average job lateness is 126 divided by 4. Are we together?
Yes, I'm getting you.
So average number of jobs in system, I'm just using the short abbreviation. You look at the total flow time. The total flow time over total processing time. So let's find it. The total flow time over total processing time. So it's going to be 318 over 130. So we find the average number of jobs in system. So let's sort out the issue. So what is the average flow time, average number of average job lateness, and average number of jobs in the system? Get a calculator. I don't know if you have a calculator with you.
Yes, 318 divided by 4 to give us 79.5.
Then the other one.
26 divided by 4 to give us 31.5.
Then the other one.
The other one, yeah.
So this is the table called we have evaluated the first come, first served table. So let us do the table now to do with the shortest processing time from here. Okay. Okay. So shortest processing time table will come from the first come, first served. Okay. So we are going to use the shortest processing time table. This one should come from where? Come from first come, first served table. So vehicle ID, then you go for processing time. Which one? Due date, the same way. Flow time and job lateness. Is that okay with you?
Yes.
So let's check here. Which vehicle are we going to start with? So an example, you cannot start with the first question in an exam when even if it came first, if it's very tough. So we'll start with the question that will take minimum time for you to finish. So which one will take so it's select the one with the shortest processing time. So it will be 226, 27, and 39. Then followed by which one? 225, right? 29 and 75. I don't know if you're getting me. Then the other one will be what?
What are we looking at?
229, 33, and 30. Then the other one will be 224, 41, and 60. We are ranking them based on which one is giving us, starting with the shortest processing time from the mother. So everything else should come from here. So you start with the one which has the job that is having the shortest processing time. So we start with this one. Are you able to see?
27.
27, this one will be number 2, number 3, number 4. This is what I'm saying. So this sequence for the first come, we will not use it. This was the first come, first served. It was the way it was. We just started it. So we're going to do a table based on it, shortest processing time. So you rank these based on shortest processing time. Is that okay?
Yes, that's fine.
Yeah. So which the table will be which way? So the table, like it comes from this mother. Or if everyone else comes, if the other sequence will come from here. So that's why I've come here to say we need to now say the vehicle ID will be 226. The one which has 27, you pick the respective due date of 39. Then the other one will give us 225, which is 29 and 25. Then the other one will be 229, which is 33 and 30. Then the other one will be 224, which will be 41 and 60. Are you with me now?
Yes.
So we are ranking based on the shortest processing time. It's this one we are using. So here flow time will be 27 plus 29 is what? 56, right?
27 plus 29. 56, yes. 56 plus 33. 89. 89 plus 41. 130.
So here on the lateness, we are not late for all those ones. Here we are late by 70. Here we are not late. Why? Because you are comparing the completion time and the due date for that vehicle. Are we together? So that's what happens. So what's it? The total here? The total is 130 for the float time. That one will be 27 plus 56 plus 89 plus 130, 302. The other one will give us what? 59 plus 7, 129. So average flow time, 302 divided by 4. Average job lateness, 129 divided by 4. And average number of jobs is equal to total flow time over what? Total processing time. Are we together? So total flow time is what? 302 divided by 130. So this one will be 2.32. I don't know if you're following.
I'm very much with you.
So this is what goes on.
So make me understand. So when you encounter such a question, you have to answer it first of all by following the components of sequencing and also using the criteria.
Yes.
Is that right?
Yes.
So the first step, we are looking at the first come, first service.
And
then now we are looking at the shortest processing time.
Based on the question.
Based on the question.
Yes. The question they asked
Okay.
You understand what I mean?
Yeah.
So the question asked us to do what? To do those. The first come, first serve. You understand? First come, first serve. Shortest processing time and the critical ratio.
And critical ratio.
Yeah.
Okay.
Is that okay?
That's very much fine.
Okay. Thank you for understanding. So that's why we are evaluating this table now.
Okay.
Yeah, this table is SPT table. It's coming from the mother.
Coming from the mother table there.
The first come, first serve table, yes.
Okay.
It's coming from the mother table. So this is on sequencing rules. Is that okay?
That's fine.
So we have actually sorted out. This is the average flow time, average job lateness, average number of jobs in the system. So let's do the critical ratio table.
Maybe before we proceed to the critical ratio,
Mhm.
because I've seen on this SPT, I think the critical thing is the ranking aspect. What was our critical ingredient on the first come, first service? What were we following there?
Boss, you are ranking them based on the shortest processing time. So here we
Okay.
shortest processing. So like I told you to say, you can't start with the question in the exam that is very difficult. So you start with the one which will give you the minimum possible time to start with to finish. Is that clear? I don't know if I've explained. So
For the SPTS, SPT, you are saying we get the shortest processing time, right?
you start with the vehicle that will take minimum time to start with to finish fast and ready to go. So an exam,
Yeah,
don't start with a question that will take more time.
which
So
is
you
very
end up just
difficult. I get you there.
you end up just answering one question and you don't finish the exam. So you do a question that will take the minimum possible time for you to start with.
I get you.
You get the point, right?
That is for the SPT, right?
Yes, you start with a job that will take you the minimum possible time to start with.
Okay, now for the first one, first come, first service, what is the critical ingredient there?
It
What do
was
we
just
look at?
don't tamper with it, just do it the way it is. Okay, that's the way the jobs are. So just work them the way they have come.
Also, you just work them the way they have come.
Yeah. So if there is one person who has come at a time, attend to the first person who came ahead. That's the first come first served. So what we use in an organization. You know, in organization, we use the first come first served. But we are trying to look at which one will be better. Will the will the Okay, will the shortest processing time be better? That's what we're trying to actually look at.
Okay.
Is that okay with you?
Yes, yes, I'm following you.
So for the first come, first serve, you just don't temper with the tempo, just sort them out the way they are.
Okay.
The way the jobs have come, work with them, just work on them. Even if they will take more time, work on them because people complain to say, I brought my vehicle earlier than this one. Why have you started working on this other vehicle? You know what I mean?
I
So,
see.
yes, so the shortest processing time, this one is telling us that no, you need to start with the vehicle that will take the minimum possible time to begin with. Is that okay with you now?
Yeah, yeah, sure, sure.
So this shortest processing time comes from the mother. So we use the information from the original table, which is the first come, first served table. So we use it from the first come, first served table. I don't know if that is okay with you now.
Very much okay.
So, and then you evaluate the table using the three criteria for each sequencing rule. We use average flow time, average job lateness, and average number of jobs in the system, which is equal to total flow time over total processing time, which is 302130 is 2.32. So now you do the critical ratio table. For ranking for this guy, for this critical ratio, you use the formula first. Do data over processing time. Rank jobs based on minimum ratio. So based, okay, on the minimum ratio. Is that okay with you?
Very much okay.
So let's go for the vehicle ID. 226. Then 229. 224. 225. What are we having on the due date is 39 divided by 27. Then the other one will be 30 divided by 33. Then the other one will be 60 divided by 41. I'll show you where these five figures are coming from. 25 or 29. So from here, we are just dividing there. So here, we are just dividing the 39 divided by 27. This is the due date. You've seen it, huh? Then this is what? Processing time. All together. So the other one will be what? 30 divided by 33.
Mm-hmm.
Then the other one will be 60 divided by 41. Then the other one will be 75 divided by 29. All together.
Mm-hmm.
So this is what we have here. So give me the ratios. Divide for me. So we'll start with the one ranking first with the smaller ratio. So divide these ones for me. Let's see what we are going to find here. What answer are we getting?
The first one is 1.4.
So this is 1.44. Then the other one,
The
30,
other one is 0.91.
0.91.
The other one is 1.46.
This is 2.59. So which one will rank first here? Which one should we start with? It's this one, right?
The one,
One.
yes, is 0.9.
Then which followed by which one? This one.
Followed by
This one.
1.44.
So what would be the vehicle ID? Then you say processing time,
99.
due date, flow time, and job lateness. So the vehicle ID is 229.
229.
So you get the processing time there is 33.
33.
33 and 30.
30.
Then the other one,
226.
226. Which is giving us what?
27 and 39.
Which one is the processing time? 27 and 39. Then which other one? 224, right?
Mm-hmm.
224, which is what? 41 and what?
41 and 60.
Then the other one give us what?
The other one is 29 and 75.
And this one is 225.
Mm-hmm. Then cumulative float time will be 33.
To be 33, yes.
Plus 27 to give
Which
us
is
60.
101.
Plus 41.
Here we are late by 3. Here we are late by what? 21, 41, 55.
21, 41, 55.
Are we together?
Yes.
Okay, so 324, 3 plus 21 plus 41 plus 55. But did you understand yesterday's class for changeover cost? It was very okay, not so?
Changeover cost yesterday was very much okay. Yes.
So 324 over 4. Average job lateness 120 over 4. Average number of jobs in the system. Total flow time over total processing time. 324 over 130. 2.49. Then that one will be, this one will be 30. 81. Okay, I'm sure you can clearly see these ones. Is that okay with you?
Yeah.
So the ranking. So this is a critical ratio table. Okay, so now what are they saying here? The question says what? After we have done what the examiner wants here, what next are they asking for? We evaluate by using those criteria. And then what next? You need to rank these ones for these criteria. Now you need to recommend the sequencing rule. Okay? You need to recommend what? A sequencing rule. So you do a summary table now. Let's do a summary table. I told you to say the smaller for each of them, the better. The smaller the lateness, the better, because I shouldn't be giving you excuses if you're my boss at the office. No, every day I'm late. Okay? So if I'm late by a small margin, yes, you can pardon me. Is that okay? So at the same time, also, if I have a lot of jobs to work on, if I have a lot of customers to attend to, okay, then my efficiency will be questioned. Why am I having a lot of customers? If actually others are even the queue is almost even outside the banking hall, then you're going to tell me, no, you can't work on cash, okay, because you can't manage the queue. So the smaller lateness, the better. The few completion time, the flow time should be minimal. I should attend to customers fast, okay? And the smaller lateness, I shouldn't give excuses to customers about my lateness for an assignment that you've given me. The smaller lateness, the better. I don't know if you understand what I mean.
Yeah, I'm getting you.
Then yeah, so this is what's happening. So we are evaluating average flow time rank, average job lateness rank, average number of jobs in the system. Then also you do the rank. Okay. So the first come, first served. First come, first served. Shortest processing time, critical ratio. What was the average flow time for the first come, first served? Let's go here. Let's get them. Average flow time. This was the first come, first served table, not so. So you are what average flow time was how much? So average flow time was 79.5, not so. Average job lateness 31.5. Average number of jobs is 2.45. 2.45. Is that okay with you?
Yes.
This is first come, first serve. Then let's go for a shortest processing time. A shortest processing time, average flow time was what? 75.5. Average job lateness is 2.25. Then average number of jobs, 2.32. Then critical ratio You see one more from doing here. Okay, average flow time is equal to what? 81. Average job lateness is equal to 30. Average number of jobs in the system is 2.49, right?
Mm-hmm.
So we come here and put them in this table. For this one, first come first served, you have 79 point what? 79.5. Average job lateness is 31.5. Average number of jobs in the system is 2.45. So this processing time, it is 75.5. Then this one is 32.25. And then this is 2.32. Critical ratio is 81, 32.49. Okay, so based on the average flow time, which one is better here? Based on the average flow time, which one? Which one is better?
It's 75.5.
Which is 1, 2, 3 here. Then this other one, the one which is better is 1, 2, 3. Right?
Mm-hmm.
Then this other one is 1, 2, 3. So what are we saying? What are we saying now in short? What we are simply saying in short is that SPT is ranking first based on this one and this one. So it has dominated. Okay. So recommend, okay, SPT to management. Okay. Because it is ranking first here based on what? So ranking first based on it. Based on the average flow time and average number of jobs in the system and average number of jobs in the system. Is that okay with you?
Yes.
Because from the three, the smaller the better, the smaller value the better. So SPT is ranking first based on it, the evaluating criteria. Otherwise, would have actually, if it was the 50-50, would have said recommend first come first served. If you first come first served, ranked one somewhere, SPT ranked one somewhere, and critical ratio ranked one somewhere, like the way it is for critical ratio here. It is ranking first here. We cannot recommend it because the dominance is SPT, but it was the 50-50 where each of these sequencing rule had where it was favoring. It was being favored maybe by average flow time, whichever one would have ranked them, recommended all of them based on the criteria that is favoring that sequencing rule. Is that okay?
That's fine.
Yeah, so this is it. How you look at this one as the sub-component of show flow planning and job sequencing, where you evaluate criteria based on this sequencing rule using the three criteria: the average flow time, average job lateness, average number of jobs in the system, and you actually select which sequencing rule is favoring which one. Okay, so this is the procedure. So regardless of each sequencing rule, we have 5 columns. the ID for the job, processing time, the due date, flow time, job lateness. So they have 1, 2, 3, 4, 5 columns for each of them. All right, so even for SPT, so we have 5 columns. First come, first serve, don't tamper with the table, just start solving it the way it is. Then these other sequencing rules come from the first come, first serve sequencing rule. Is that clear?
Very much clear.
Yes, so we have sorted out the aspect of the sequencing rules. Then yesterday we did changeover cost or setup cost. I think you remember this question. I'm sure it's not.
Yeah, I don't know.
I
So that one, the question I had is that because that one we had done too.
Uh-huh.
Are you getting me?
Yes, yes.
On the changeover cost, we had identified 2 variables there.
Which is in the
the other
5
5
here.
and the
5 and 5.
and our resolution was based on comparing the 2 from whichever sides we started from.
Yes.
So now my question is, what if there is only one column which has got a smallest value?
Okay, so
Where
meaning,
do you compare it with anything, or the answer you find that is the final answer?
yes, the answer is just 1. You just do for that
The
same.
answer will just be 1, right?
Yes, yes, yes. But if there are 3, you will do for all of them and select the one which will give you the
And compare.
and compare.
Okay. Okay.
Is that okay? Is that
Okay.
okay with you?
Very much okay.
Yeah. So what I would do, I need you to have a fresh mind for the last part of this topic, because this last part is it needs you to have a fresh mind. This one is not
No,
this one. Again.
I don't mind. We can just proceed so that because that last part, that means we complete this topic, right?
Yes. Okay. If you are okay with
So
it.
that the next session we look at the other topic. At least if I'm able to get 3 topics right, then I'll know that I'll pass the exam.
Okay, no problem. Yeah, okay. So let's look at I'll get this question 5. This question 5 was on shop floor. Okay. So it's on shop floor planning. Are we together?
Yes, I'm following you.
So the first question 5, part A, was also on shop floor planning. So this now is not on sequencing. This one is on Gantt chart. Okay. So it's on Gantt chart. So for this Gantt chart, we use the concept of we use the Johnson's rule. So the concept is what is important. So from here you can see we've tackled the sequencing rule, changeover. So Johnson's rule, last part. So let's do the last part quickly. So this Johnson's rule states that, so this man came up with this aspect of saying that you cannot fix the tires to the bicycle if you haven't done the frame. Okay, so this guy says that, Johnson's rule states that if the shortest, okay, processing time for the job is in work center 1 or machine 1, do that job first in the schedule. Okay. But if it is in work center 2 or machine 2, okay, work center 2 or machine 2, do that job last in the schedule. Okay. So This is it, how this man came up with this one. Okay, I don't know if you are able to see.
Yes, I'm able to see and follow you.
Okay, so there's this question or this question in the pamphlet. The one question A, sequencing rule. Question B was using Johnson's rule. Have you seen this question here? Yeah, so if we do this one, you in one time try this one, the one that came in okay, that came in this exam paper. Okay, for 15 marks. Usually this one carries more marks than the other one. So I don't know which one you would want us to do. Select either. Can we do this one or the other one? Which one do we do?
Let's see the other one.
There's this one. Or the other one. Which one? We can select either, not so.
Yeah, let's do this one.
Okay, so how many shipments do we have here? It says what? You can read for me quickly. So that is
The company receives parts from suppliers to be used in its manufacturing departments. The quality control department must perform two operations when shipments are received. One, Operation A, draw a random sample package and deliver to test. And two, Operation B, test the material and issue a disposition report. There are currently 6 shipments waiting to be processed. The time estimates to process these 6 shipments through quality control are those times. There are 1, 2, 3 shipment up to 6.
Yeah.
Then operation A, the times are there. B, also the times are there. Use Johnson's rule to set the sequencing of processing the shipment through quality control.
Okay, all right. Then how much total time is required to process all the six shipments required? So here I can put this one on my whiteboard. So on this one, you have operation A, operation B. Okay. So 1.5, 1.1, 1.2, 0.7, 1.6, 1.9, 1.0, 2.7, 1.4, 1.6, 1.5, 2.9. So which one is the shortest processing time? You are using the Johnson zero here. Which one is the shortest processing time for all these times that we have? Whichever way, wherever it could be. If it is in operation A, do the job first. So you have the shipment here. Shipment 1, 2, 3, 4, 5, 6. So whichever way we are looking at this, which one is the smallest time for all these times?
0.7.
Where is it? Is it in A or B?
In A.
So you do the job which shipment or job. So you do job 4 first. So job 4 to be done first, and cancel this one from here. Complete has been done. The remaining job for the remaining times here is what?
The other smallest is 1.0.
Where is it?
It's in B.
So you do shipment 1 at last here, because in B. So do shipment 1 at last here. So I put the 4 here. 1 comes here. These act as boundaries now. These act as boundaries. Okay, so cancel it. It has been done. Let's go to the other remaining time. Is what?
1.1.
1.1. Where is it?
It's in A.
So 2 comes here. Okay, you cancel it. Which other one is the remaining time for the shortest remaining time?
1.2. Which
So
is in
3.
A.
So 3 here. And they also cancel it out. Which one is the other remaining time for these ones?
1.5.
So 5 is here. Because it's a 5, this job. So 5 goes. Then the other remaining is 1.9. So 6 comes here. And then so this is a job sequence. That's all. That's how we get a job sequence. So a Gantt chart is drawn based on the job sequence. Gantt chart is drawn based on it. This is a job sequence. So this is where the Gantt chart is drawn. If you have understood the sequence, so it's 4, 2. So this is how the sequence should be. Okay. From here, this is part B. So the sequence they obtained there was this one, them. 4, 2, 3, 6, 5, 1. 4, 2, 3, 6, 5, 1. Okay. So it Lucy Johnson's rule. The sequence was 4, 2, 3, 6, 5, 1. 4, 2, 3, 6, 5, 1. Let's confirm. 4, 2, 3, 6, 5, 1. This is what we have gotten. So this is a sequence. So once we get the sequence correct, then well and good. Then you do a Gantt chart. Is it okay so far?
Yes, yes.
All right. So now let's do a Gantt chart now. So for Gantt chart, you simply say A and B. I want you to take extra time to follow this Gantt chart. It's very easy, but it goes with additional maths. We just use additional maths as we are going with this other side. Okay, so the sequence job is this same one. So what are we starting with is 4. Okay, it's the same job that should run in both the centers A and B. So it's how many hours is it taking in A? 0.7, right? Are you with me? It's taking 0.7, right? So. So meaning that these people, they are waiting for this job to fully complete. So they are at this point, they are idle. These guys, they are idle. They are waiting for the same job. It's running, still running. They can only attend to the fixing of the tires or painting. If they are binding this job, they're printing this job, meaning these people to bind, they should wait. Is that okay? Now it has been printed, so they should start binding it here. So it's taking how many hours to be binding it in B? The same job, 1.6, right? How together? It's taking 1.6 here. Okay, is that okay?
Yes, yes.
Don't lose me where we are. Don't lose me, please. Be with me.
No,
right?
I'm with you. I'll tell you. If I lose you, I'll tell you. Right
Don't
now,
lose.
I'm with you.
So now,
So right now, we have picked the exact time. The time for A, they are spending to do the work, and also the time for B, they are spending to do the work.
At this point. So the guys in department A, they have already printed 4. So they should start printing what? 2, using this sequence, right? You should start printing what? 2. 2 is taking how many hours? In A, 1.1, right?
Taking 1.1, yes.
Okay. So 1.1, you come here and put 2 here and put 1.1. So what is happening here? What's the difference between 1.1 and 1.6? Subtract for me.
Between it?
1.1 and 1.6.
1.1 minus 1.6.
The difference is what?
0.5.
So why
0.5.
So 0.5. That 0.5, I'll put it here. Let me show you where I'm going to put it. It's here. Okay? 0.5 here. Are we together?
And it's in negative. Why are we not doing it the other way around?
Why is it negative?
You said 1.1 minus 1.6 is negative
I'm
0.5.
saying 1.6 minus 1.1. That's what I said.
Okay.
Mhm.
Okay. I hear you now.
Okay, so it's fine. So we're getting which one? What's the difference here? The 0.5,
It's
right?
5, yes. 0.5, yes.
Okay. So don't lose me here, please. So this is the difference between this job and this job. Okay. By the time they are, these people, by the time these people are still binding this job for, these people in Department A, they would have finished what? Working on job what? On job 2. All together. Is that okay?
Yes.
And they have enough room to start working on job 3 while these people are still working. Because these ones are taking excess of 0.5 hours more. So let's do, so they can start working on job 3. Job 3 is taking how many hours? In A?
1.2.
So come here and put 1.2 here. Job 3 here is taking 1.2. So meaning it's taking how many hours longer? It's a difference between from here to here. Are you with me? And hello?
Yes, I'm getting you.
From here to here and here. So that these people are taking how many hours longer? 1.2.
So we subtract 1.2 from 0.5.
You can subtract the 1.2 from 0.5. So it's 1.2 minus 0.5. So it's the other way. So these people are taking how many hours longer?
Mm, 0.7.
Yeah. So why do we put the 0.7? It's here. 0.7. Have you seen?
Mhm.
So don't lose me here, please. So now, job 4 is fully complete. Job 2, it hasn't been fully completed because it doesn't run in B. It doesn't be, they haven't, this one is not yet bound. It's not supposed to bind this one. Okay, in Department B, right? So 2 in Department B is taking how many hours? So by the time they're printing, finishing printing, job 3, the people in Department B, they were supposed to start doing what? Binding job 2. Okay, 4 is fully complete because there's run in A and B. 2 is not fully completed. So 2 in B is taking how many hours?
2.7.
So 2.7. So we come and say 2.7. So it's 2 here and it's 2.7. So this 2.7 is taking how many hours longer? It's taking 2 hours longer. 2.7 minus 0.7 here. I don't know if you are getting my point, right?
Yes, I'm following you. I'm just trying to devise a strategy on how to understand it better. So it's just about subtraction, eh?
That's why I told you to say this one, be assured to get additional marks. That's why I told you to say this one. If you don't understand now, we can bounce back and we come and do it again for another question. Okay? As we revise. Is that okay? So no worries.
That's fine.
No worries. So this is what is happening. So we're doing additional maths. So we're comparing. By the time they're finishing this one was running in this department. It was taking how many hours? It was taking 2 hours. So 2.7. So it was taking how many hours longer? It was taking actually, okay, how many hours? It was taking 2 hours longer. Is that okay?
That's fine.
So you put 2 hours here. Okay, so this is what's happening. So now you can see by the time they're finishing binding 2, these people, they would have already finished the printing 3. So they would have switched on to 6. Okay, are we together? So 6 is taking 1.9. 6 is taking 1.9. So 6 is taking 1.9. So you can even come here and say 1.9 will be somewhere here. You know what? You can estimate. You can just see that 1.9 can be somewhere here, right? So this is 6, 1.9. Because from this whole area here, okay, from here up to here is 2, right? Are we together? From here up to here is 2. So, okay, so this is what's happening. Is that clear?
Very much clear.
So here, these people, they still have a 0.1 they still have excess time. These ones they still have 0.1 hours for them to continue finishing doing what? Binding job 2. Okay?
Where does the 0.1 come from?
The difference between 2 and 1.9.
Was it not supposed to be the other way around? From the other side we are coming from, we are subtracting from.
You know what you are doing here? What we are doing here, we are looking at the x's where we are taking longer. That's why we are subtracting. So,
Okay.
yeah, so where we're taking longer is why we're subtracting. So here it was 2.7, we subtracted the 0.7 to get the 2 x's. Is that okay? So here, it was a 2. It was a 2 from here up to here. Okay? Then this one only took 1.9. So meaning these people, they still have excess of 0.1 hours running. Wow, these people, they have already finished printing job 6.
I see.
You know what I mean? So they have even have enough time to start working on job 5 now. Job 5 is taking how many hours? 1.6. Okay? Job 5 is taking 1.6, meaning that the 1.6 here, you will come and say job 5, 1.6. So this one, they'll be taking 1.5 hours longer. Why am I subtracting? Because it to go off. So you know what I mean? So it is asking 1.6 minus 0.1. Okay? 1.6 minus what? This 0.1.
1.6.
Minus 0.1 here. Minus 1.5 longer. So by the time they're doing job 5 here, job 4 is complete, job 2 is complete. So job 3 will start running in department B. Job 3 in department B is taking how many hours? Job 3 department B is taking 1.4. So 1.4. Come again?
It will be 0.1.
So it will be 0.1 somewhere. So 1.4 here. Okay, 1.4 is here. So job 3. 1.4. So there's a 0.1 here extra when you compare from here up to here is 1.5. So there's a 0.1. So meaning these people can now start running job 6 because 4 is complete, 2 is complete, 3 is complete. You can start running job what? Job 6 in department B. Job 6 in department B is taking how many now? 2.9. Okay? But here there's an extra of 0.1 here. There's a 0.1 here. You see 9? So this one, job 6 is taking how many? Job 6 is taking 2.9. So meaning it will be taking 2.8 hours longer. 2.8 hours long. From a 0.1 there. Are we together?
Yes, I'm following you.
So now, what is happening here? 4, 2, 3, 6, 5. It's just 1 which is remaining. So these people are supposed to start running job 1, which is 1.5. So here, job 1. Okay. Job 1, which is 1.5. So you compare 1.5. These people, they have excess. So subtract 1.5. 2.8 minus 1.5 is what?
2.8 minus 1.5.
1.3. So meaning what that I mean is that for them to be at par with this one, they are finished. So they are idle here. They have begun being idle. Okay? Because they have finished all the jobs. So they are idle by 1.3 for now. And they have finished all the jobs. 4, 2, 3, 6, 5, 1. They have finished working on them. So these people should just now, but they shouldn't knock off. What is it? They are working together. 4 is complete, 2 is complete, 3 is complete, 6 is complete. So 5 should complete here. Okay, so 5 should complete. So 5 to complete is, so 5 should complete. Okay, so 5 to complete is taking how many hours?
One 5.
5 to complete is taking how many hours?
1.5.
1.5, right? 1.5. So these people are still idle. These people are still idle. So if it is 1.5 is an idle time, okay? So 1.5 here. So this one, these people are still idle here. So these people are still idle here. So the total idle time for A. Idle time for A will be 1.3 plus 1.5, right? Then idle time for B, it is just the 0.7. Which 0.7? Just this part here. You get the point, right?
We haven't finished the job A. I mean 1. We've ended on 5. The other guys, we ended on 1.
Oh, okay. So no problem. Yeah. So we need to also finish. You are very right. So you also need to finish job what? Job 1. So 1.5 and 1 should come here, right? 1 is taking how many hours? 1.0. 1.0. Is that okay?
Yeah, that's fine.
So all this time, these people in this department, they are idle. So 1.3 plus 1.5 plus what? Plus 1.0. So it will be 1.3 plus 1.5 plus 1. 3.8 hours. The night time for B is only 0.7. So total time required now. Total time required. So this is what I told you about this Gantt chart to say you need to be very careful. You get the point, huh? You would need to do proper additional maths here. So we are adding, you can either add, so you're adding all those ones, 1.9 plus 1.6 plus 1.5 plus C 1.3 plus 1.5 plus 1. There's a 1 here. So give me the chance. 0.7 plus 1.1 plus 1.2 plus 1.9 plus 1.6 plus 1.5 plus 1.3 plus 1.5 plus 1. 11.8 hours. Are we together? Even similarly for B, use for B. 0.7 will give you the same answer, plus 1.6 plus 2.7 plus 1.4 plus the 2.9 plus 1.5 plus 1. Give me the answer for this one. So these are ours. So the total time required should give us what? So 0.7. Give me the answer. Add for me this one. What are we getting? I'll give you 2 minutes to add.
Okay, 0.7 plus 1.6 plus 2.7 plus 1.4 plus 1.5 plus 1. It's also giving me 11.8.
Okay, so 11.8. Thank you very much. So this is the Johnson rule and Gantt chart. So whichever way, okay, these people, they are waiting for each other for them to knock off. It's not that when they finish printing, they have to knock off. So they were waiting for each other to knock off. So this is about it, how we are putting the answer. So you can even check, confirm the answer. This is the diagram they came up with. So here, they just said idle time was this whole thing. But for me, I was trying to explain to you how even here they had put idle. But and they found the total time was 11.8. Have you seen it, right? Okay, so you do additional maths for you to get this one. You aggregate as
So now let me understand, where are we getting those times? Like for A, I know on the table, are we just picking what is on the Gantt chart? I know where 0.7 is coming from. Okay, 1.2 is coming from. Then 1.2. Okay.
Yeah, these times here.
And plus my idle time Pamwamba Paja. Okay.
These ones.
Also, these the ones who were finding my differences, we are not considering them, right?
Those
We
were
are just picking.
But those ones we're not considering them. Those ones were just assisting us to move forward, to see.
Too late. Okay.
To see the discrepancy in terms of the departmental areas, which ones they were able to finish faster than the other one. You get the point, right?
I see.
So we were just aggregating to see who between the two departments were finishing earlier than the other one, so that if there was any other room for them to continue. Like here, 1.2, 1.1 for job 2 and 1.4, 1.6. These people were taking longer by 0.5. So these people in A, they had no time to waste. They could quickly switch on. Because this department B, they're depending on the guys in A for them to work. Okay? I don't know if you get my point.
Yes, I've seen. Yeah.
Is that okay now? Have I cleared your issue?
Yes, you have, yes.
Okay, so you do just addition. As you are going this side, you see, okay, which one is taking longer? Can these be people, by the time they're finishing here, what was happening in this department? Then you look at the time they're taking, and the time they're taking this other department. So look at the difference. What is the difference? You put the difference there. Where the other one is ending, you also put the difference as you are going forward. So let me give you the homework to do. Okay, the homework we can do is because these questions are recycled, because you can't master these. You can just know the answer is 11.8, maybe if he's going to repeat it, but you need also to understand what's going on. So if you go for May 2023, try to do question 5B, question 5A. You have these jobs, printing and binding. So we'll come up with a job sequence. We can come and sort out this together in the other class, if you don't mind, before attending to the other topic.
Okay, no, it's clear.
It's clear, right? So we have exhausted the shop for planning and job sequencing. That one is mandatory. You will find it in an exam, because this one doesn't miss. So what you have understood well and good, especially for the changeover course that we did here. Okay, go through and the sequencing rules that we are from doing today. I'm sure you are okay.
Yeah.
Okay, so in the other class we can do the other topic, which is maybe
Yes.
maybe the maybe